do that, then we get that x is equal to 0.20, which is actually pretty close to what you get if you do an isentropic expansion. Okay. So I would say this number here with this simplest case, for at least for water, is a pretty good approximation. Right. If it turns out that CP, if the temperature difference that you're looking at is large, and the CPs for that liquid, right, is very different between the two conditions, then the second one is probably better, and it's not very likely that you will have, thermodynamic tables for that component. So those are the two you have to work with.
I'm just trying to get an idea of what you mean by significantly different, like a factor of.
Well, I would say, right, anything to, right, 18 to 22, I would say, right, that's, if we get that close, it would be good, but if we're starting to look at between, differences between 20 and 30%, right, then we need to be a little bit more accurate if the differences are that much. So if the if the results are 20 to 30% in the fraction rate test, for example, because of what you do, then I would trust the more accurate one, right? And if it's really that different, then getting your thermo book back and actually look at the functional CP is probably the best. And then you plug it into your calculator. Right? So I'm gonna leave you here since we had a quiz today. We're gonna switch and do the problem solving on Thursday instead. Okay, so but this is, and I will, like I have done, like I do for thermo, if you had me in thermo, I will upload a file that says materials covered, and I'm trying to update it so that you know exactly what has been covered, what will be part of exam 1. And I'll put up suggested problems. The exams are up there. I'm gonna upload solutions to the 2013 and the 2014 one. The 15 one, I'm going to go over on Tuesday. So I'm going to not upload the solutions to those. You can work that on your own and then see on Tuesday, right, how, right, I'm just going to go over what my thinking was when I designed the exam, okay? And then any other, if there's a problem in the book or that you want me to go over, let me know and we'll go through that on Tuesday. Or on Thursday if you're right. If there's a problematic, something that you're struggling with, just let me know and I'll go over that.
There's not going to be homework posted this week?
So no, since we have an exam, I might, the suggested problems will be your homework.
Why is this 7 right here?
Just vote.
I don't know. Let me see it closer.
Dude, people don't ever get it. Have you ever heard my text thing? It is literally, it's like, hey, listen. People are like, what the hell is this?
Why is that 7?
Why is it 7 feet? Because it's the difference between
Because that's the initial height.
yeah, that's
Oh,
the
yeah.
initial height. The initial height changes from that hole, not to the final. Yeah, people that are always trust me.
It is. It makes you want to check your text.
It goes off all the time. Today somebody texted me 10 times in a row. I was like, hey, listen.
Why is it 7? Is the hole 7 feet off the ground? That's why. The HL is the distance from the hole to the top of the liquid. Like from here to liquid level is the HL.
it wasn't part of this. Yeah. You know, I forgot to.
It's not that many. If you had to send an email every time.
There weren't any angry notes or anything.
Yeah, I mean, it was something, but so the question that I had of
Yeah.
26.
Or I'm waiting for Yasmin.
Oh,
There's no sense of reasonableness with these problems.
33.
33.
Could be right.
Yeah, I got 900.
Oh, that's
My
the
units
one.
might have been off. Could have been third pounds dying or something.
433 is the one I
Dimes.
think I put it.
Yeah.
I put it with the
You're
3 points.
telling
I don't
me
have my solutions here.
Use
So
that
what
as my
was the?
spectroscopy course.
Dude, my spectroscopy course has gotten awful.
Because we were talking about, oh, you know, we're just gonna approximate all these
I remember.
chemical bonds as
So
a quantum harmonic
you
oscillator. So it's
you're
like a spring, and
calculating
the spring
an
constant's
A,
about
the
1.5,
minimum
like
flow
5
rate
times 10 to the
that will
5th
give
dynes.
you-
And I'm like, why are we using
Right,
dynes?
that
It's
will
like, come on.
completely cover.
Dynes are
And-
just a really old
and,
CGS system.
For
the
what?
minimum
For
flow
So
us?
rate
CGS
would
was
be equal
designed
to the
in order to
evaporation
make,
rate over the thing.
like,
What does it measure?
it measures,
Oscillations. Isn't it something to do with
And
oscillations?
B,
isn't it?
you
It's a
were
spring
asked to
constant,
calculate
so it's
the
a
concentration,
force.
right,
It's a
based
force?
on that.
yeah, it's a,
Or,
like it's.
Yeah, it has to be a
and so
force.
even though the flow rate.
Right, but the
even
whole
though
idea of the
flow rate
CGS
is
system
bigger,
was in order to
it's 1
redesign
kilogram.
the
That was
unit
a trick,
system so that
right? It's
as you
bigger,
do
but
really,
it's liquid
like you work with
flow
really small
rate.
things,
So
the
that's
numbers,
what- it's
like
only
it doesn't
gonna
blow up
fill
your
out
calculator.
the dot.
Yeah, it's in your
Right,
calculator.
so the whole thing is your calculator can do it, but then eventually you start doing quantum mechanics stuff and you realize that it's still
So you
terrible
have
because
to
you'll have
use
things
the
like
flow
h
rate
bar
to
to
calculate an
cubed.
A
And you're like,
to
so
do
Planck's
the
constant is
problem.
already times 10 to the negative
I
34.
thought
Then I divide that by 2
uploaded- that's
and
why
then I
was
cube
late
that.
putting up the
My
solutions
calculator doesn't like that.
because I
So they
made a
decided
note
to
at the
redo
very
everything in
bottom
atomic units, and you're like,
saying
the
that,
mass of an
you know,
electron is
the 1
1.
kilogram is
Yeah, I got
liquid.
it.
And so then you're like, h bar
And,
is
you know,
1.
We're
whatever
doing
goes
NMR
into
right
vapor
now, and
is
it's
what
gotten
calculated
worse.
as gain, and that's what you
It's
have
gotten
to
bad, dude.
Bro, I've
This
got
is why
gas
I'm
nuts
not.
on that
We finally moved on to
happy with
NMR from FCIR.
them
and,
using QN.
strangely enough, we didn't have, like,
It's-
she didn't
it-
test
you
us
know,
on
they don't distinguish
Multi-system. Multi-system.
vapor,
Well,
which is
you
very
look at the
important.
graph and you're like, what's the
Yeah.
difference
Yeah.
between that? And you're like, there's
The
no
calculation has
Yeah.
to be
Shit's
vapor,
fine.
but you're calculating
Gotcha.
But the
liquid
problem
flow
is like
rates
multi, you
and
have to have
the
large,
source
like,
models for
the polydiversity has to be
liquids.
like